Key statistical concepts. In stats, we collect information on a group of things, and then we analyze that information to come with conclusions. That's basically it. So let's go over some common language terms we all need to know. Population. That's just what you're studying. So whether it be people, dogs, cats, number of cable subscribers, number of students at Almont, whatever the whole thing you're studying is, that's population. Let's call our population the Almont student body. So all like 1,400 students. Census, when you collect information from your whole population. America does this every 10 years, where they go around and try to count every single American, which helps determine the number of houses, the number of seats in House of Representatives. For our population here, we would literally have to go talk to every single Almont student. Getting information from the hosting device would be kind of tedious. So instead of what we do a lot of times, we just take a sample, which is where we get information from a small subgroup of the student body. So like maybe we just ask every homeroom in the 100 wing. We'll go get information from them, and we're going to get the same results with a lot less work. Survey is one of the many ways to collect data. You just go around and pass the survey out. There's also an observational study and an experiment, but IB only cares about the survey, so we'll just ignore those. Okay, let's talk about two things we're going to focus on in a lot more detail in the future. So that's distribution and outliers. Distribution is just the patterns that your data falls into. So it could fall into a symmetrical pattern, where like all that is in the middle. Now this one's a little interesting because it looks like a lot of people did bad on the test, but there's a few people that did pretty good. So that skews it. We call that positively skewed because it's higher than it should be, right? There's a lot of low scores, a couple good ones. The trick is, let's look at the tail. That lets you know, oh, it's positive. Over here, it's the opposite, right? So a lot of people did well, but a few people that did bad, so it's negatively skewed. Right? Just look at the tail right there. Next up is outliers. That's all data that falls outside the normal data set. So like, let's say you had some data like this, and they had one up here. That would be the clear outlier. Like, what's that thing doing? Or if you just look at the test scores, let's say like you had an 81, and then like an 84, a 93, an 87, and then you had like a 15 on one. That would be the clear outlier. Like, what was going on there? Now let's talk about what numbers you could get when you talk about your data. The first type is a discrete numerical value. So those have to fit a certain pattern. So like these cannot be any number. Cannot be anything. Be any number. They fall on a certain type of number. So like here's some good examples. Number of people in a car, right? 0, 1, 2, 3. Score on a test, right? You can't get like a 13.1765 on a test. You can't get 2.13 people in a car. So those are examples of a discrete number. It has to be a certain set. I always like to say shoe size. Just think about shoe sizes, right? They come in like 4, 4.5, 5. You can't get a 5.136 shoe. So that's discrete. The other type of number is continuous. Now, continuous could be any number. That's the key thing about continuous. You could be any number is possible. So here's some good example of a continuous. Your height, right? Your height, you're not exactly 5'10". You're like 5'10", 2.176 inches or whatever. The speed of a car, right? It doesn't go straight from 62 to 63. At some point, you're like 62.41 or something like that. So anything could be any possible number. Like there's not set values for you. That's continuous. That's a continuous type of data set. Now let's move on to frequency tables, which frequency tables allow you a nice way to organize your data set. So let's look at the data set right here, right? So if we want to count all the ones, we're just going to go, there's one right there, right there, right there, 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 and there. So that's 8 total. So you can do a little time mark if it helps you, but really you don't need to. That just shows you there's 8 ones. If you count them all up, there's going to be 9 twos, 6 threes, 5 fours, and 2 fives. So that's a frequency table. Notice on the bottom here, it's a total. So there's 30 total numbers there. So you don't have to count, there's actually 30. This right here you're going to see sometimes, but not always. It's a relative frequency. Not the biggest deal in the world. All it is they get, there's 8 ones, and then you get 8 divided by the total number, 30. That's where you come with that number there, right? So here's going to be 2 out of 30, and you get 6.7. So that's frequency tables. Next, there's lots of ways you can display your data. The two most famous ones are column graph and frequency histogram. Column graph you use when it's discrete data, right? That's why it's all separate, because you can only be a certain number. And then frequency histogram, where you just, as you tell, no gaps, but all connected. That's to show that it could be any number you want. So if you have discrete data, use column graph. If you have frequency histogram, use continuous data. Before I miss this right here, the modal class, just as the mode, we'll talk about mode, median, and mean later, but that's essentially just the mode. So it's this, what's the most often table you see here. So the modal class will be this thing there. The modal class here will be this one, because it happens the most often. So that's all a modal class is. And finally, let's move on to a couple examples. So in this first one here, they give us 20 juvenile lobsters from a tank of several hundred. So randomly select 20 lobsters here, and they want us to organize in a frequency table and then do some stuff with it. So let's look at here. So they want me between 3 and 4. So how many lobsters between 3 and 4? So there's one here, one here, and here. So it looks like 3. So there should be 3 lobsters. Between 4 and 5, 1, 2, 3, 4, 5, and 6. So there's 6 between 4 and 5. Between 5 and 6, right? 1, 2, 3, 4, 5. 5 of those. Between 6 and 7, so 1, 2, 3, 4. So 4 of those. And finally, between 7 and 8, looks like there's only 2. That one and that one. So that's my frequency table. Next, they want me to state the modal class. That's the one that happens most often. So you could look right here and just kind of tell, oh, it's between 4 and 5. There's the most of those. So that's the modal class. And in describe distribution, there's lots of ways you can do that. I actually a lot of times find it easiest to graph it, like a quick little crappy graph, as I always draw. So 3 and 4, let's do that one here, and then 4 and 5, and 5 and 6, 6 and 7, 7 and 8, then kind of go 1, 2, 3, 4, 5, 6. That's all I need to go to. So this goes 1 and 3. This continuous data, so I should make it all connected, but I'm gonna have a hard time doing that. This one goes to 6. I'm going to try and make it all connected. This one goes to 5. So let's go around there. The next one goes to 4. So let's go around there. The next one goes to 2. So like essentially that. Right now I want to look at the type of distribution it has. If you kind of like follow it, it's a positive distribution, because right here, right? Positive. Look at the tail. And that's that problem. Final example. So right here. So in this one, if you look at it, the plant inspector takes a random sample of 6 months of old seedlings from a nursery and measures their heights to the nearest millimeter. We're also showing the frequency histogram. So again, it's continuous data because it's all connected. I'm not going to do this one like detail by detail, but I'll just kind of talk about it. And how many seedlings are 400 millimeters or more of height? Well, let's look at your graph here. So here's 400, right? So it's all those. I'm gonna have to like estimate it. It kind of looks like it's 14 plus 6. So I'll say like 20. It's about 20. That's an estimation. What percentage of seedlings are between 349 and 400? So they want to know how many are between 349. So like 349 is essentially 350 and 400. So these data sets. My bad drawing. Wow, that's terrible. But anyway, what percent of seedlings are between 349 and 400? So again, you have to estimate it. This looks like it might be around 42. This one's gonna be looks like, let's say 28. So you're gonna get 42 plus 28. And then again, it wants percentage, so I gotta divide by the total. I'm not actually sure what the total is. I gotta add them all up, and I'm too lazy. So let's just put total. Right, because they want a percentage. Then look at these last two right here. The total number of seedlings in the nursery is 1462. That's not this, because remember we took a random sample, so this is just a random sample. It's not going to be 462 up here. But they're saying the total number is 462. Estimate the number of ceilings from which the measure is less than 400. So less than, it's kind of like a combination of the last one. Less than 400 is all this. So you got up all those numbers there. So again, this looks like it might be like 12. So let's say 18. You're going to go 12 plus 18 plus 42 plus 28 divided by the total, which again, too lazy to look for. And then since they want you to estimate the 1462, the census they took, basically the whole thing, that's going to be a percentage there. You just multiply that by 1462. And that'll get you a rough estimate of how many of them are less than 400.